This is the first lesson on solving radical and rational equations. Equations means that we have an equal sign. Radicals means we have some sort of root or radical. And rational exponents, actually we need to put exponents in there. Just means it could be written as a radical or it could be written with rational exponents. So we're going to look at the first type. So our goal for this is to solve these equations. EQNS is equations. And check for extraneous solutions. Now, this is one place, you know how normally they say, well, you can plug it back in and check your work. And everybody says, yeah, I know that I can do that, and you don't. This is one case that, especially this case, is super important because you may come up with a solution algebraically, but when you plug it back in, because you have a square root or a fourth root, you can't have a real solution if that negative is underneath that radical. It would be imaginary. So an extraneous solution is a solution that doesn't work. Okay, so let's look at our first example here. Our first example is going to be something like this. Example number 1, if I have 9 plus x equals 18. Now, I know this sounds simple, but I want to use what we do here to our example. So the stuff on the outside of the x, we want to get rid of that first. So in this case, it would be the 9. So I'd get rid of the 9. And then I get that x, or whatever that represents, is equal to 9. So now let's look at our first question. Example number 1, that was kind of like a preview. So if we have 9 plus the square root of p plus 9 equals 18. All right, so this is kind of our thing that we are isolating. So what is on the outside? The 9. So we're going to get rid of the 9. So we have the square root of p plus 9 equals 9. Now, that square root, we need to get rid of the square root. So the only way that we can get rid of a square root is by squaring the square root. So if it was a cubed root, we would cube it. So I'm going to square both sides, and I end up with p plus 9 equals 81. Subtract my 9, and I get p is equal to 72. Now, this is where it's super important that we go back and check. Well, 72, if I plug 72 in, 72 plus 9 is 81. The square root of 81 is 9. 9 and 9 is 18. So that solution checks. So there is one example. Another example would be something like this. What if I have, let's do 6 plus 2 square roots of x equals, let's do 4. So the way I used to talk about this, I did this with absolute values as well. When we're solving an absolute value equation, we do very much the same thing. We get rid of the stuff on the outside of those absolute value marks. Well, in this case, I have a radical. So I'm going to get rid of the stuff on the outside of the radical. I used to call them boogies. Get rid of the boogies hanging on the outside of this radical. So if we kind of think about this question, this question kind of looks like this. So we have to peel off, what would we peel off first? Well, we would peel off our 6 first. 2 square roots of x equals negative 2. All right. Now, if I had 2x, I would divide by 2, so I'm going to do that here too. So I'm going to divide by 2, and I get the square root of x equals negative 1. All right. The way I get rid of that square root is I'm going to square it. And I get x is equal to 1. Now, this is where we check for extraneous solutions. So, if I plug 1 in for x, check for extraneous solutions. So I'm going to plug it in. Is 6 plus 2 square roots of 1 equal to 4? Is 6 plus 2 equal to 4? No. So there is no real solution. We don't have to write I, we don't have to do anything like that. We're just going to say no real solution. So let's go back and look at the problem and see where we could have possibly seen that. Looking up here, I know that 6 plus something, this something's going to have to be negative. There's no way a negative's coming out of that to give me 4, because it's decreasing. I could also look here. Is it possible for the square root of x to equal negative 1? It's not. So I could have picked it up there. Or getting it and then plugging it back in. I have no real solution. So this is an example of an extraneous solution. All right. Let's look at another type. What if we have I'm going to have you do one on your own here, and then I'm going to pause the video, work it out, and then show you. So example number 4, what if you had 5 plus 2 square roots of x equals 3 square roots of x minus 4. Now, think about the problem in terms of, what if it said 5 plus 2p equals 3p minus 4? How would you solve that problem? So, go ahead and do this. I'm going to pause the video and then I'll turn it back on and show you the answer. All right, so here's the example written out. I'll go ahead and kind of leave that there for just a second. You can pause it and check what I did, and then we're going to go on to one more example. Okay, we're going to look at examples 5 and 6. I'm going to go ahead and let you write those down, and then I'd like you to pause the video, and then I'm going to start you on 5, and then I'd like you to pause the video and go ahead and work 5 and 6 out, and just check your work when you're finished. So, with number 5, I have a radical equal a radical. So, I'm going to square both sides. And when I square both sides, I'm going to end up with x minus 7 equals 3x minus 60. I cannot split this apart. It has a minus sign under a radical. You can't separate it like you can with multiplication. That is just one package. It would be like saying that you went to buy a PlayStation and you're going to rip the cord out and just have the cord separate. That PlayStation is in one box that includes the cord. So, a lot of you freak out because we have a fraction. Not a big deal. Let's multiply each and everything by 7. And when you do that, then your fraction will go away and you end up with something like this. A few people might freak out a little bit because I have a 21 and I have an x. Subtract your 21x from both sides. So at this point, I'd like you to pause the video and I want you to go ahead and work both of those questions out and then come back and check your work. All right, not all of it is going to fit on the screen here. So I'm just going to kind of move it and you can kind of rewind your video. You end up with 21 and 1. And then I have the check step here, in case anybody wants to see that check step. All right. We have one more type that I want to show you, and then this video will be at the end. So let's do something with irrational exponents. So what if I have, so this is example number 7. What if I have something that looks like this? 3x minus 2 raised to the 1/3 power equals 4. Now, that's really just saying the cubed root of this, right? So, how do we undo a cube root? We cube it. Now, these two things cancel each other out. I'm left with 3x minus 2 equals 64. Add 2 to both sides. I have 3x equals 66. And I have x is 22. And if I plug that in, 3 times 22 is 66, minus 2 is 4. And the cubed root of 4, or it's 64. The cubed root of 64 is 4. All right, so that takes care of our first two main types. We have some more advanced problems that we're going to do in the next video.